While solving the problems of normal distribution, we must first understand how to read the normal distribution table or the Z table, which measures the probabilities. For finding probability, it is always a good idea to sketch the graph, that is the bell curve. So this will be always our first step to solve a normal distribution problem. Now the normal distribution problem takes the types like between, more than, or less than. When we want a probability or the area for more than 1.833 here, that is, the area will be beyond this 1.833 and it will be this total area on the right hand side of this z equal to 0, which is 0.5, minus area between z equal to 0 and z equal to 1.833. This 1.833 can be read in this normal distribution table as 1.8 plus 0.03, that is 1.83, and it takes the value 0.46638. So the area more than 1.833 is equal to area in the right half, that is 0.5, minus area between z equal to 0 and z equal to 1.833, that is 0.46638, and the resultant area required, which is denoted by this yellow color, comes out to be 0.5 minus 0.46638, that is 0.03362. Likewise, if we want area below or less than this minus 1.833, the same logic will be applied, that is the total area on the left hand side, that is 0.5, minus area between z equal to 0 and z equal to 1.833. So resultant area will be same for both the sides. Now if we want area less than 0. minus 0.988, then it will be again 0.5 minus area between z equal to 0 and z equal to minus 0.988, that is 0.98. So it is 0.5 minus 0.33646 and it comes out to be 0.16354. Now the next type is when we want the probability or the area equal to lying between z equal to 0.8 here and z equal to minus 1.933. So this is area between z equal to 0 and z equal to 0.8 plus area between z equal to 0 and z equal to minus 1.933. So here we have this 1.933, so it is 0.47320 and this is our 0.8, 0.28814. So adding these two values, we will get the total area of this shaded region and it comes out to be 0.76071. The third type gives area between minus 0.316 and minus 1.221. So the difference between these two curves is that this lies on the either side of z equal to 0, whereas this particular area lies on only one side of z equal to 0. So here to get this area, we have to calculate the area z between z equal to 0 and z equal to minus 1.221, this total area minus area between z equal to 0 and z equal to minus 0.316. So first, if we get the area between z equal to 0 and 1.221, so this is 1.22, So 0.38877. So this is the area between this line and z equal to 0. And next we take area between z equal to 0 and 0.316. 0.316 can be rounded up to 2, so that we take the area as 0.12552, and the difference between these two values will give us the area denoted by this shaded region. So further we can solve examples using this particular concept of reading the normal distribution table. Let us solve the example. A radar unit is used to measure speeds of cars on a motorway. The speeds are normally distributed with a mean of 90 km per hour and standard deviation of 10 km per hour. What is the probability that a car picked at random is traveling at more than 100 km per hour? So here clearly the speeds are normally distributed. This means the speed is our random variable. The speeds of cars is the random variable. The mean is given as 90 and standard deviation is given as 10. Next, what we want is the probability that a car is traveling at more than 100 kilometers per hour speed. So our x is greater than 100. So the very first step to solve the problem of normal distribution is to draw the rough sketch or the bell curve. So here we have to assign the values. This is our mean 90, and now we want to convert it into standard variate, that is z, and it comes out to be, for x equal to 100, z comes out to be 1. And what we want is probability of x greater than 100, and therefore we want probability of z greater than 1. So for calculating probability of z greater than 1, we have the right hand side probability as 0.5, and we need to get the probability between z equal to 0 and z equal to 1 from the standard distribution table for normal distribution, and it comes out to be 0.5 minus probability between z equal to 0, z equal to 1, and this probability, if you refer the normal distribution table, you will find it as 0.3413, and your resultant answer is, the probability is 0.1587. Another example says that assume that mean height of soldiers is 68.22 inches with sigma square, that is variance 10.8. How many soldiers in the regiment of 1000 would you expect to be between 6 feet to 6.5 feet? So to start with, our random variable is the height of the soldiers, for which mean and variance is given to us. Mean is 68.22 and variance is 10.8, and positive square root of variance is our standard deviation, which is required here, that is 3.28. X, if it is 6 feet, that is the height of the soldiers, we have to calculate it in between. So we have to take two values of x, that is x equal to 6 feet, x equal to 6.5 feet. But all other measurements of mean, standard deviation are in inches, and therefore we have to convert this x into inches. So 6 feet is 72 inches, and our standard normal variate z becomes 72, that is x minus 68.22, that is mean, divided by standard deviation 3.28, comes out to be 1.15. On the same lines, x, which is 6.5 feet, that is 78 inches, gives us standard normal variate 2.98. So what we are going to calculate is probability between x as 72 inches and 78 inches. So it becomes z between 1.5 and 2.98. So the very first step to draw the bell curve. So here the particular shaded region is on one side of the mean, and therefore we need to calculate area between this z equal to 0 to z equal to 2.98 minus area between z equal to 0 to z equal to 1.15, so that we can get the required area. So area from z equal to 0 to z equal to 2.98 can be observed or noted down from the normal distribution table, and it comes out to be 0.4986, and area between z equal to 0 and z equal to 1.15 is 0.3479. So required probability that the number of soldiers between 6 feet to 6.5 feet in a regiment of 1000 comes out to be 1000 into 0.1507, which is approximately equal to 150 soldiers. Again, an example of sample of 1000 cases. Mean of a certain test is 14, standard deviation is 2.5. Assuming the distribution to be normal, we have to calculate how many students will score between 13 and 15. So the score of the student is our random variable here. Then mean is 14, standard deviation is 2.5. So we have to find how many students score between 13 and 15. So for x equal to 13, our standard normal variate z becomes 13 minus mean 14 divided by standard deviation 2.5. It is minus 0.4, and for x equal to 15, z becomes 0.4. So what we have to calculate is the probability between 13 and 15, that is probability of z between minus 0.4 to 0.4. For this particular bell curve, so the area between minus 0.4 and 0.4 will be addition of the areas between z equal to 0, z equal to 0.4 and z equal to 0, z equal to 0.4. So we can simply make it as twice of area between z equal to 0 and z equal to 0.4. As the values on right and left are same and the areas are to be added, so we can make it 2 times, and from this normal distribution table you can find area from z equal to 0 to z equal to 0.4 as 0.1554, and our desired result is for sample of 1000 cases. So 0.3108 multiplied by 1000 gives you approximately 311 students scoring between 13 and 15. That's all for the examples of normal distribution.